Now, let's try some more examples. Example 2. Find the vertical and horizontal asymptotes of fx equal to 1 over x squared when x cannot be 0. From this question, we know that fx is undefined when x equal to 0. It means that the function is defined for all real values of x except 0. Now, how do we find vertical asymptote? We test the limit for the function 1 over x squared when x tends to 0 from right, and limit 1 over x squared when x tends to 0 from left. We do direct substitution for both limits. The first one, 1 over nearest value of 0 from right, and it equals to positive infinity. Second, by direct substitution, 1 over nearest value of 0 from left square, it becomes positive. So, the answer is positive infinity. Thus, we might conclude that x equal to 0 is the vertical asymptote. Next, how do we find horizontal asymptote? To find horizontal asymptote, we always test limit x tends to positive infinity and limit x tends to negative infinity, and the function given is 1 over x squared. For both functions, it becomes 1 over infinity, and 1 over infinity is equal to 0. Therefore, we might conclude that y equal to 0 is the horizontal asymptote. Example 3. Determine the asymptotes of fx equal to 1 over x squared plus 5x minus 6. Let's start with vertical asymptotes. To find vertical asymptotes, we need to find the values of x for the function fx is undefined. For this function, x squared plus 5x minus 6 cannot be 0. By doing factorization, we have x plus 6 times x minus 1 cannot be 0, and x cannot be negative 6, and x cannot be 1. Therefore, we need to test limit x tends to negative 6 from right and limit x tends to negative 6 from left, and limit x tends to 1 from right and limit x tends to 1 from left. Now, we need to test the limit to find the vertical asymptotes. Let's start with limit x tends to negative 6 from left. By substituting the nearest value, we get negative value multiplied with negative 7, and the answer is positive infinity. Next, Limit when x tends to -6 from right. By substituting the nearest value, we get positive value multiply with -7 and we get negative infinity. Limit x tends to 1 from left. By substituting the nearest value, we get 7 multiply with negative value and the answer is negative infinity. When x tends to 1 from right and we substitute, we get positive 7 multiply with positive value and the answer is positive infinity. Therefore, we might conclude that the vertical asymptotes are x equal to -6 and x equal to 1. How about horizontal asymptote? For horizontal asymptote, we always test limit x tends to positive infinity and negative infinity. For this function, we have 1 over infinity and it equals to 0. Therefore, we might conclude that y equal to 0 is the horizontal asymptote. Example 4. Determine the asymptotes of fx equal to x minus 1 over x squared minus 1. By looking at this function, we might factorize the denominator. So we have fx equal to x minus 1 over x plus 1 times x minus 1. Thus, we simplified the function to fx equal to 1 over x plus 1. Let's start with vertical asymptotes. To find the vertical asymptotes, we need to find the value of x when the function fx is undefined. Therefore, x plus 1 cannot be 0 and x cannot be -1.
So, fx is undefined when x equal to -1.
Vertical asymptote. How do we test limit at x equal to -1? First, limit x tends to -1 from left for the function of 1 over x plus 1. Second, limit x tends to -1 from right for the function of 1 over x plus 1. We substitute the nearest value, we get 1 over negative value. Therefore, the answer is negative infinity. Second, we substitute the nearest value of -1 from right, we get 1 over positive value. Thus, the answer is positive infinity. And we might conclude that x equal to -1 is the vertical asymptote. Next, horizontal asymptote. For horizontal asymptote, we always test limit x tends to positive or negative infinity for the function of 1 over x plus 1. For this function, we get 1 over infinity. And 1 over infinity is equal to 0. Therefore, we might conclude that y equal to 0 is the horizontal Asymptote.